Our first lesson in the Congruent Triangles unit involves classifying triangles, or naming triangles would be another way of saying this. A great deal of this is review for most students, but those of you that did not go to school in the United States will find there's a number of new vocabulary words. In addition, the simple basic diagrams from elementary and middle school are long gone, and the diagrams that we're going to use on the tests and the quiz are going to involve a lot of annotation on your part in order to figure things out. So our essential question today is, how do I classify triangles? All right, so triangles are classified by the types of angles and the lengths of the sides. And this means that every triangle has two names. If all three angles in the triangle are acute, it is an acute triangle. Do not just write the word acute. Okay, it's an acute what? An acute angle, acute triangle, an acute polygon. We have to be more specific than just the word acute. If there is one obtuse angle, then it is called an obtuse triangle. It gets pretty tedious writing the word triangle over and over and over again. So fortunately, we can use a little baby triangle as our triangle symbol. All right, if one angle in the triangle is obtuse, what can you tell me about the other two angles in this triangle? The other two angles must be acute. Think about this. All three angles in a triangle add up to 180 degrees. So if you subtract out the obtuse angle, let's say 100, just to pick an easy number, we only have 80 degrees left to split between the other two angles somehow. No matter how you split that value, you're going to end up with acute angles. If there is one right angle, then it is a right triangle. What can you tell me about the other two angles? Yes, the other two angles must be acute. There is an angle pair relationship here. I'm going to pause the video a minute. All right, I started recording before class started, and the tardy warning music there came on, so I paused until that was over. So the two acute angles in a right triangle have an angle pair relationship. What is that angle pair relationship? They have to be complementary. Let's stop and think about that for a second, right? The three angles add up to 180 degrees. We subtract out 90 degrees for the right angle, and the other two remaining angles have to add up to 90 degrees. That's the definition of complementary angles. If you have three acute angles, it is called equiangular triangle. Three acute angles would be equiangular. Three congruent sides, equilateral. Now, equiangular and equilateral always go together. Always. All of the other types of angles and sides are mix and match. Okay, but equiangular, equilateral triangles are always together. Two congruent sides is isosceles. I suggest you take a little time and make sure you know how to spell that word. And no congruent sides, scalene. Now, in terms of vocabulary, you have to make me a note card for scalene equilateral, isosceles, and equiangular. Acute triangle, obtuse triangle, and right triangle, it is your choice whether or not you make note cards for those. All right, moving on. Let's practice. Using this diagram, classify each triangle by its angles. Classify means to name. Okay, so our choices are acute, obtuse, right, and equiangular. All right, triangle CDE. CDE. Then I've got the right angle symbol right there at E, so this is a right triangle. BCE. That one is clearly obtuse. Triangle. ABE. Equiangular. Triangle. Equiangular triangles. All three angles have to measure what? Let me back up here. All three angles in an equiangular have to measure 60 degrees. Right? 180 divided by 3 is 60. Important information. Let's see. BDE. BDE. Obtuse. And CFE. Acute. Make sure you've either written out the word triangle or drawn the triangle symbol with all of these names. If you fail to do that on the test or the quiz, I will mark it wrong. All right, next up, using the diagram, classify or name by the sides. All right, pause your video for a moment and try these three. All right, check your work. We had a scalene, an isosceles, and an equilateral. Okay, the isosceles had the double tick marks that I've done in green, and the equilateral had single tick marks there in red. Now this one is a beautiful diagram, and this is more like what you're facing on a test or a quiz when it comes to naming the triangles. If PR bisects angle SRT, so what does it mean to bisect an angle? It means to cut it in half. So let's look at SRT. SRT is here. And it looks like the top half is 30 degrees, so the bottom must also be 30 degrees. We have that U is the midpoint of RT. Okay, here's RT. Here's U. What does it mean to be a midpoint? Again, it means we're cutting that segment in half. So if this half is 8, so is this. Classify each triangle by both angles and sides. So 2 names for every triangle. Now let's take a closer look at this diagram before we dive in. Let's start at the top right. I've got a right triangle, 30 degrees, 60 degrees, a leg that's 8, a hypotenuse that's 16. I've got a leg I don't know the length of, but I can use the Pythagorean theorem to figure it out. So let's see, 8 squared plus x squared will equal 16 squared. Uh, 192, I believe. So x is the square root of 192. Let's see, can we simplify that? 296, 2, 48. Okay, I have 3 pairs. 2 times 2 is 4, times 2 is 8, so this is 8 times the square root of 3. Let's label that. Okay, coming to the triangle immediately below, I notice it's isosceles, right? And that means this side length has to be 8 because the congruent side is also 8. Let's see, I can figure out this angle measure. 180 minus 120 is 60, minus 30 is 30 degrees. Continuing to go clockwise. I've got 8 and 8 and 60. Let's see, I've got a linear pair here with 120 at U. So 180 minus 120 is 60. Looks to me like I've got an equilateral. That also has to be 60. Then my last triangle. Angle Q, I have a right angle, vertical angle theorem. 16 and 8. I've seen that before. Oh, the triangle on the top right and the triangle on the bottom left are congruent triangles to each other. So this has to be 8 square root of 3. Opposite the 8 meters would be 30 degrees, and opposite 8 square root of 3 is 60 degrees. Now that I've annotated this diagram, I can actually answer these 6 questions below. So pause your video for a moment and do that, please. Okay. I think number 2, RST, was interesting because 3 of the smaller triangles get put together to make that particular triangle. All 3 sides are 16, and all 3 angles are 60, which made it equiangular equilateral. The rest were individual triangles, so a little easier to see. All right, next up. What about on the coordinate plane? And we can still classify even though we're only given ordered pairs. So if we want to classify a triangle in the coordinate plane, we start off by using the distance formula. Right? If all 3 side lengths come out the same, it's equilateral. If 2 come out the same, it's isosceles. If none come out the same, then it would be scalene. After that, we need to use our graph and our slope formula to determine the angles. We can get a right angle if we have opposite reciprocal slopes. Right? Opposite reciprocal slopes mean we have perpendicular lines, and perpendicular lines meet at a 90-degree angle. Okay, so let's go ahead and graph this, because sometimes we get lucky and we have vertical and horizontal lines. Okay, I am not lucky here. No vertical or horizontal lines in this particular triangle. You know, vertical and horizontal lines are always perpendicular, so that would have given us a right angle right away. Just judging by the picture, what would you guess this is going to be? Now let's figure out what it actually is. So let's start with our distance formula. And you know you must write it down every time you use it. It's really important when you solve these problems that your work is clear. I don't want to do D equals D equals D equals, because then which line segment am I talking about? Let's start by talking about KL. And so I'm going to label it KL. All right, and you don't put the bar on top because we're talking about a measurement. So let's see. of the nice things about these is you don't have to simplify your radical to solve it. When you're doing this work, I expect to see the radical sign throughout every step on your process. We talked about this back in Unit 1. Do not drop the radical sign from your work. It's sloppy algebra. I also expect to see equal to signs between the steps. Don't drop that equal to sign. It's sloppy algebra. Now let's try KJ. Let's see here. Oh, this is interesting. KJ and KL have the same length, so they are congruent. I have an isosceles, maybe an equilateral. We're going to have to do that third side to decide. So now we're doing JL. This looked equilateral to me when we got started, but it's not. JL isn't much bigger than the other two sides, but it is a little bit bigger. And so we have an isosceles for sure. Now we need to make a decision about angles. Okay. Just by looking at the graph, I can tell there's definitely no obtuse angles up there. Acute or right angles are the possibilities. I can prove right angles using slope. In a right triangle, in order to have a right isosceles triangle, the right angle has to be between the two congruent sides. There's no other way to have a right isosceles. So I need to check out angle K and see if I have a right angle. So I am going to do the slope of KL and the slope of KJ. And I'm literally going to do it by doing rise over run on my graph. So KL, 1, 2, 3, 4, 5, 6, 7, 8. Negative 2/8, which is negative 1/4. KJ, negative 8/2, which is negative 4. These two slopes are not opposite reciprocals, so I do not have a right angle. This triangle is acute isosceles. Now, I am going to star this problem because I guarantee you there is one like this on your exam. You have to show your work neatly. Everything has to be neatly organized and labeled. And you will have to classify based on the sides using ordered pairs. All right, I'd like you to take a minute and write me a sentence or two about how to classify triangles for your summary.